Hello and welcome to a video on applying right triangles. We're going to use some of the skills that we have acquired so far in trigonometry to solve some challenging word problems. So here's our first word problem. Alexa's friend got a skydiving lesson. She's jumping out of this helicopter. And we want to find, we're supposing that she fell in a straight perpendicular line from the helicopter to the ground. How far away from the skydiving center did she land? So we're solving for this distance right here in our right triangle. I'm going to call that x. Okay, so first things first, the angle in the problem is given to be 20 degrees. So go ahead and make sure your calculator's in degree mode. If you hit the mode button, make sure that degree is highlighted, and if it's not, you can move the cursor onto degree and hit enter, and that way you'll be in degree mode. If the problem gave you angles in radians, then obviously you need to go into the mode and set your mode to radians. Great, so I believe all these questions are going to be in degrees, so we can keep our calculator in degree mode for all of the problems in this video. So the first thing to notice here is if I wanted to solve for a side in a right triangle, a lot of times what we're used to doing is the Pythagorean theorem. So let me say I'm going to call the height here y. So if I wrote out the Pythagorean theorem as it applies to this scenario, I would get the equation x squared plus y squared equals 3.4 squared. And now my goal here is to solve for x, but look at what's going on. There's two variables now in this equation, so I cannot uniquely solve this. I can't figure out the exact value for x. And now that I have these, that I also don't know y. And this is where trigonometry comes in. We can use basic right triangle trigonometry, use either the sine, the cosine, or the tangent function to write an equation for this particular triangle to solve for this side. So let's see what information we know here. We know that this angle is 20 degrees, and this side right here, this side x, the side we're looking for, that's the adjacent side to the angle. And we're given that the hypotenuse in this triangle is 3.4 kilograms. So I could write a cosine equation. I could say the cosine of the angle, which is 20 degrees, equals the length of the adjacent side, which is x, over the hypotenuse, which is 3.4. And now I just need to solve this equation for x. So if I want x to sort of be isolated here, I'm dividing x by 3.4. What I need to do is I need to multiply both sides by 3.4 to sort of clear my denominator. And I get that x equals 3.4 cosine of 20 degrees. And then I'm going to go ahead and I'm going to type in 3.4 times the cosine of 20 degrees right into my calculator. And I'm going to make sure I round to 2 decimal places, which means I'm rounding to the hundredths place. So it looks like I get 3.19 kilometers for my answer. So in Khan Academy, I would just go right up here and throw in the 3.19, and I would get that correct. So notice sort of we have two sort of techniques in our arsenal now. We can write trig equations, like this one, to solve for a missing side. Notice that we're using one of the known angles. So it's like I know this 20 degrees, I know the hypotenuse, I don't know the adjacent side. I could write an equation using the cosine function and solve for that adjacent side. If I happened to know the height that the helicopter was off the ground here, if I was given this height at the start of the problem, then I could have just done the Pythagorean theorem, x squared plus y squared equals 3.4 squared. If I knew y, then I could use the Pythagorean theorem to solve for x. So in a lot of these problems, you'll be using the Pythagorean theorem, and in a lot of them, you'll be using trig, and some you'll have to use a combination of both. So let's look at the next question here. Archaeological excavations reveal a leaning, huge tower buried in the Guatemalan jungle. The archaeologists measured the tilted sides of the revealed tower and found that the shorter right side is 32 meters long, this side right here, and the longer left side is 50 meters long, and we want to find the height of the tower, which I'm going to label h. And look what's going on here. We have two right triangles. So we've got this one right here. I've got this right triangle, and then we've got this other right triangle here. And we need to solve for the height. So I think this is going to be a case where I'm not going to be able to do the Pythagorean theorem, because I know 32 squared plus the length of this side squared equals 8 squared, but I don't know the length of this top side here. Same thing with this triangle. I could set up the Pythagorean theorem, but I wouldn't have enough information to uniquely be able to figure out what h is. So I'm going to use some trigonometry. So the first thing to notice here is that this sort of is a key piece of information. This is a right triangle in the problem, and this angle is theta. So this angle must be 90 minus theta, because both of these angles have to add up to 90. And if you know that this one's theta, and you know that they add up to 90, then if you did 90 minus theta, you would know the other one. So that's a very important concept that we're going to be using a lot. So let's look at this triangle right here. If this angle is theta, and this is 90, well, I know that all three of the angles have to add up to 180 degrees. But if this angle down here is 90, then these other two must add up to 90. So if this angle is theta, this angle down here is going to be 90 minus theta. And then I can use the same logic in this right triangle over here on the side, that if this angle is 90 minus theta and these two added up to 90, this one must be theta. So down here, let me just write that out, because if one of them is theta, and I add that to 90 minus theta, like what do I get? Well, the theta minus theta is 0, and I'd be left with 90. So that's sort of a key concept that we're going to be using a lot when we label our triangles, that if you call one of the angles theta in a right triangle, you've got theta, you've got the right angle, and then that third angle is going to be 90 minus theta. So now I'm going to write some trig equations that involve sort of the height here, but I want to sort of write the same trig equation. I want to sort of use the same trig equation. So like let's look at this triangle here, and let's look at theta. So I know that the adjacent side to theta is 32, and I want to find the height, so I could write a cosine equation. Cosine of theta equals 32 over h. So basically in the other triangle, I'm also going to write a cosine equation. Because, like, notice here I've got these two variables. So maybe in the other triangle, if I wrote a cosine equation, I could set my two cosine equations equal to each other if I'm using the same angle. So here I'm going to use this theta here. So what's cosine of theta? The adjacent side is h. The hypotenuse is 50. So in the other triangle, we've got cosine of theta equals h over 50. Now look at what we have here. We know cosine of theta is 32 over h. We know that cosine of theta is also h over 50. Well, both of these expressions equal cosine of theta, so they must equal each other. So 32 over h must be the same as h over 50, and now that's an equation we can solve. Let's just cross multiply. We get h squared equals 32 times 50, I believe is 1600. Square root both sides. We get that h is 40 meters. So I would go over here, type in 40. Khan Academy has been nice and already labeled in the units for me. Great. So again, look at what's happening here. We don't have enough information to do the Pythagorean theorem, so we can write some trig equations using either the sine, the cosine, or the tangent function, and those trig equations helped us solve the problem. And then we needed some extra, trickery here. We needed to know that, if one of the angles in a right triangle is theta, then the other angle is going to be 90 minus theta. That was key to labeling all of our angles there. So we know what all the angles were, and we could write some trig equations. Awesome. So let's look at a word problem where we have to solve for an angle. So Bob is building this cabin. He wants to know what should be the angle between the roof beams and the cabin. He wants to know this angle. And the problem told us that he was placing this beam so it would be directly in in the middle. He wanted to place the roof beam in such an angle that each pair of the opposite beams would meet exactly in the middle. That's sort of key to the problem. So these two roof beams are meeting exactly in the middle here. Well, if this whole length here is 30 units, then that means from the midpoint here out to the vertex there, that's going to be 15, because those beams are meeting right in the middle. So notice, just because this base length was 30 here, that doesn't mean that I can assume that these two sides are 15 and 15, just because this is 30 in the way the picture looks. But the problem tells me that he wanted the opposite beams here to meet right in the middle. That's what allowed me to then dice that up into 15 and 15, because that's the way he was building his house, so to speak. So now look what's going on here. Oh, I know two sides in the right triangle. I could do Pythagorean theorem to find this length right here. 15 squared plus y squared equals 17 squared. I could solve for that length. Oh, but I don't even need to solve for that length, because really what I'm just looking for is this angle down here. So again, I'm going to write a trig equation. So I'm looking for this angle. I'm going to call it something. I'll call it theta. So I'm looking for this angle theta, and look what I got here. I know that the adjacent side to theta is 15. I don't know the opposite side, and the hypotenuse is 17. So what trig equation involves adjacent and hypotenuse? Cosine. So cosine of theta equals adjacent, the length of the adjacent side, which is 15, divided by the length of the hypotenuse, which is 17. I didn't pick all these problems to use the cosine function. That's just sort of happened this way. Okay, great. Now, this does not tell me what theta is, though. This is telling me that the cosine of theta is 15 over 17. I want to know what theta is, and so this is where we need to use our inverse trig functions. So if I want to sort of isolate theta here, I'm going to take the cosine inverse of both sides. I'm going to take the cosine inverse of the left side, and I'm going to take the cosine inverse of the right side. And then on the left side, the cosine inverse of the cosine function, that'll just leave me with theta. And then I can do the cosine inverse of 15 over 17 on my calculator. And since I'm still in degree mode, the calculator is going to give me an answer in degrees. And they want us to round to 2 decimal places. So I got 28.072. So I'm rounding to 2 decimal places, which is this spot right here. So I look at the next number, the 2, but that's below 5, so I'm not going to round up that 7. So my answer is going to be 28.07, and then Khan Academy already put in the degree symbol for me there. Boom, 28.07 degrees. So there's some examples of using trigonometry to solve some word problems. These are pretty challenging, so just try not to get frustrated and ask for help when you need it. And you're going to do great. Good luck.